Like some time back, we discussed types of electron transition that can occur within the molecules. We discussed that there are generally two types of molecular orbital, bonding and anti-bonding. In bonding molecular orbitals, you have sigma, you have pi, and you then have non-bonding electronic molecular orbitals. Okay, so bonding, anti-bonding, non-bonding. In bonding, you have sigma and pi. In anti-bonding, you have sigma star and pi star. Okay, so the outer electrons, I am reading out the point given in green background. The outer electrons in an organic molecule may occupy one of the three different energy levels. Now, when we are saying we are considering only occupied orbitals, okay. First, the sigma electrons, they are bonding electrons, possess the lowest energy level because they are more stable. And why sigma bond is stable? There are many reasons. Let's not go in that basic. I hope, let us assume that you have that knowledge and you understand that sigma electrons are residing at the lowest energy level. That's why they are most stable. Then second, pi electrons. They are bonding electrons of higher energy than sigma electrons. Then comes non-bonding, also called as n electrons. They are atomic orbital of heteroatoms like nitrogen, oxygen, halogen, sulfur, which don't participate in bonding. They usually occupy the highest level of ground state. So the third type of electrons are non-bonding electrons. Let us see. Just call one of the student. देखते कोई जग रहा सो गया. Miss Preeti Yadav, can you tell me how many electrons are there in non-bonding orbitals of oxygen molecule? In oxygen molecules, how many n electrons are there? I am not asking about orbitals, I am asking electrons in the orbitals. I will repeat my question. I am not I am not asking about oxygen atom. I am asking about oxygen molecule. Very good. Abu Talib has answered it correctly. You have 8 electrons in non-bonding orbitals. Let us see how 8. This is your oxygen molecule. Every oxygen has two sets of non-bonding orbitals, and every set has got 2 electrons. So 4 electrons on one oxygen atom and 4 on other. So oxygen molecule overall has 8 electrons. Very good. Good thinking. Now, in same oxygen molecule, now I think this answer will be comparatively easy. In same oxygen molecule, how many pi electrons are there? Rishikesh, very good. Excellent, excellent. See, this is the only one of the orbital. ये जो दो लाइन मारे हैं उसमें से एक ही लाइन है that is representing the pi, you can say p orbital, pi bond. So there are only 2 electrons in that pi bond. It's further simpler. In the same oxygen molecule, how many sigma electrons are there? Okay, now students have started giving the answer. There will be 2 electrons which is forming the sigma bond. So there are over there. Okay, let me clear the ink on the slide. Now, we are not just interested in how many electrons are present in sigma bond, pi bond and non-bonding electronic orbitals, molecular orbitals. We are more interested in that transition because energy is absorbed by the molecule only in place. So, in excited state, sigma electrons occupy an anti-bonding energy level denoted as sigma star. The transition is termed as sigma to sigma star transition. It is denoted by like this, sigma to sigma star electronic transition. When electron from sigma molecular orbital acquires and goes to higher energy level, it is sigma star. It is denoted by sigma to sigma star in this manner. You draw a sigma letter, then draw one arrow, then draw sigma and write asterisk rank. So it is sigma to sigma star. Similarly, for n bonding of pi, you have pi star. Okay. While n electrons, they may jump into pi star and sigma star also. देखो मतलब क्या है, one electron in sigma can jump to sigma star, electron from pi can jump to pi star, and n electrons can jump to n2 sigma star also, n2 pi star also. People, have you understood this much? Please tell me yes or no. If you have doubt, you may ask. Okay, let's proceed now. Now observe this slide and tell me, out of these three, which of the electrons have got lowest energy, medium energy. You may unmute and tell me, or you can simply type down. In these three orbitals, which orbital has got the least energy, the medium energy, and which one has the highest energy? The answer is right there on the slide. So nobody is answering. I got this. Okay, now I am getting the answer. Oh, people were typing down. That's why they didn't give answer. Sigma is lowest, pi is intermediate, n highest. Very good, Zenat. Sigma low, pi high, and n highest. Very good, Anjali. Bonding lowest, anti-bonding moderate. Prabodh, you are wrong. Anti-bonding will always have highest energy. Okay. Kailash, pi to sigma. Okay. Okay, very good, very good. I'm very happy that you people are thinking and you're thinking on the right path. If you draw the energy level diagram, sigma orbitals will be the lowest one. Then you will get all of your pi orbitals. Then you will get all of your n orbitals. Now these two are bonding. This is non-bonding. All your anti-bonding orbitals will be in this region. Now this is how happens. You observe this animated diagram. It's written in the red letters. Okay, what happens is basically, let this complete, I will tell you. See, this is your pi bond. Okay, cloud above and below the sigma electrons, and there is sigma electrons also. Okay, one of the p orbital because of the higher energy, and now you have got pi star over here. So you have one electron in pi, the other has gone to pi star. The rotation of the p orbital is causing this. When the rotation is flipped back, the electron falls back to the ground state. Let's go a little deep into this. The possible sigma to sigma star, pi to pi star, n to sigma star, n to pi star. We have just now seen that n electrons can jump into pi star also and sigma star also. Now, there are two more transitions, sigma to pi star and pi to sigma star. These two transitions, they are not possible, like they are forbidden. If you they are observed only in calculations, like only in calculation. Theoretically you can say that it can be possible, but it never happens. So these two are called as forbidden. Let us see one by one all the transitions. Sigma to sigma star, what happens in it, where they are observed? Any guesses where sigma to sigma star transitions will be observed? In which molecules transition from sigma to sigma star will be observed? Very simple answer. You are I am asking in which type of molecules you get sigma to sigma star transition. Okay, I will not elongate that mystery. A molecule having sigma bonds only, sigma electron from orbital is excited to corresponding anti-bonding orbital of sigma. When this is possible in any of the molecule, the sigma to sigma star transition is possible. The energy required for this transition, the reason being, see, the sigma molecular orbital is very stable, low energy by itself. If you orbital, the electrons in that orbital, you need to require very large amount of energy. When we say large amount of energy, the energy of electromagnetic radiation of shorter wavelength. The relationship between wavelength and energy, shorter the wavelength, higher is the energy, higher is the frequency. Okay, so like for methane, CH4, it has CH4 bonds only, and star transition, and you will get absorbance maxima at 125 nanometer. Now there is one concept here. Now absorbance maxima is, suppose there is one molecule like methane, and for UV range of 190 nanometer, to say 400 nanometer. Remember this. The over this range of electromagnetic radiation, methane CH4 will absorb UV light definitely. But yes, if you can take spectra of UV even below 190, you will get maximum absorbance 25 nanometer. You will get maximum absorbance at 125 nanometer.